So today we are going to talk about polynomial division, specifically long division and synthetic division. So to start off, we're going to remind ourselves about how to find zeros. So here's our first zero that we're going to do, x minus 4. What value makes this 0? Well, that would have to be x equals 4, because 4 minus 4 is 0. X plus 6, well, that's right. Well, let's see. If this equals 0, we would subtract 6. X equals negative 6. Finally, 3x minus 2. Well, if this equals 0, the first thing we would do is add 2, meaning 3x would equal 2. Divide by 3. X would equal 2/3. Well, now we're going to work backwards, writing the factors. So, just like before, in the end, if it equals negative 9, that means it would be x plus 9. I could have gotten that by adding 9 to each side. If it's positive 4, x minus 4. And finally, well, let's see. First thing I would do is multiply both sides by 4. Oh, that looks horrible. And then 4x equals 3, minus 3, minus 3. 4x minus 3. Well, there are two ways to divide polynomials, by long division or a process called synthetic division. First, we're going to remind ourselves about long division. But to do that, I'm going to remind you about some things with long division. So if I was to say, let's do 17,645. So that's our final thing. So 17,645. And I wanted to divide that by 5. The process we would do is we would first say 5 divided by 1 is nothing, so 5 divided by 17 is 3. There are 3 5s in 17, so 3 times 5 is 15. And even though 3 times 5 is positive 15, we are going to subtract that, leaving us with the 2. So we pull down our next number, which is 6. 26, well, I know 5 goes in 5 times because it goes to 25. That leaves us 1. We pull down our next number, 4. Unfortunately, it's almost 15, but it's not quite, so it only goes in twice. That's 10 minus 10, 45. That leaves us with 9. And that's how we do long division. You might remember that. But the question is, what would happen if this had been an 8 and not a 5? Well, if it had, we would have been left with a remainder of 3, which means if I wanted to write out this whole thing as a full number, I would have to either keep dividing and get 0.6, or I could do 3,529 and 3/5. Notice I'm taking the remainder and dividing by what I'm dividing by. That might come in handy in just a minute. Long division. So here's what we do. The first thing I do is I write this part, x squared plus 2x minus 30 divided by x minus 5. So because this is two terms, I'm going to write my first one over the x. So I have to ask myself, what would I multiply x by to get x squared? And the answer is I would multiply it by x. So just like before when I was dividing by 5, I'd multiply what I'm dividing by what I'm saying it divides into. So x times x is x squared. X times negative 5 is negative 5x. But just like before, I'm actually subtracting both. Now notice, whenever I say I'm subtracting, what happens to the negative? It becomes a positive. So I'm really adding that section now. So these cancel. 2x plus 5x is 7x minus 30. That's our new equation. So in order to get x to turn into 7x, I would have to multiply it by 7. So this becomes x plus 7. Let's see, 7 times x is 7x. 7 times 5 is negative, sorry, not negative 5, negative 35. But remember, they change signs. These cancel out, and this becomes 5. So that is our remainder. So our final answer would end up being x plus 7 and 5 over, remember, it's divided by whatever we're dividing by, so x minus 5. Let's try another. 2x to the 4th, 6x cubed, plus 5x squared, minus 45, divided by x plus 3. Now, this is where we're going to discuss something very important. As we look at this term right here, what you should be noticing is that we have a quartic term, being the 2x to the 4th. We have a cubic term, 6x cubed, a quadratic term, 5x squared, and we have a constant, but we are missing a linear term. When we divide, we do not want to be missing that term. So as I write this, I'm going to write 2x to the 4th plus 6x cubed plus 5x squared minus, sorry, I forgot to do what I was just talking about, plus 0 minus 45. Then I divide by x plus 3. So let's see. This part right here, I would need to multiply what by x to get 2x to the 4th? That would be 2x cubed. So I'm going to put that with the cubed part. So that would become 2x to the 4th. That would become 6x cubed. But I have to subtract them, meaning both parts are gone. That leaves us with a 0 right there. And that 0 is going to come up to our next term. So now that we have that, we can move on. That 0 becomes, so next we are going to do 5x squared plus 0. How? No, I would have to multiply this by 5x in order to get 5x plus 3 to become 5x squared. So this becomes 5x squared and 15x. But remember, I'm subtracting, meaning negative 15x minus 45. And in order to get this part, I would have to multiply all of this by negative 15. Negative 15 times x is negative 15x. Negative 15 times 3 is negative 45. But those both change signs, meaning they all cancel out and there is no remainder. So our final equation would be 2x cubed plus 5x minus 15. And that is how we do long division. But let's talk about synthetic division for a second. You know, synthetic division is a simplified process for dividing, which eliminates all variables and exponents. However, and this is important, it can only be used when dividing by a linear polynomial. So what this basically means is synthetic division makes everything look cleaner because we eliminate a lot of the x's and x squareds and x to the 4th. We don't have those when we're actually doing the math. We just put them back in at the end. But, and this is the big issue, we can only do this whenever we're dividing by something like an x plus 5 or an x or a 7 or something like that. We cannot do it whenever we're dividing by anything else. So, with that in mind, let's try a few. But you know what? Rather than continuing on and trying a few new ones, I want to go back and do one of the ones that we did with long division. Let's start with our first one. I can teach you the process with this. So our first step is that we're going to take the same blue part right here, the part that I used underlined in blue, x squared plus 2x minus 30. Now I'm going to write the coefficients to this part. So x squared, the coefficient is 1. 2x, the coefficient is 2. And with our constant, I'm just going to write negative 30. Please make sure to include things like negatives if that's the case. Now that we have that, I'm going to take my other term and find my 0. So in this case, my 0 is 5. My first step is I drop down my first number. That's now 1 again. But then what I do is I multiply 1 by 5. So that's 5. Then 2 plus 5 is 7. So now I'm going to multiply 7 by 5. 7 times 5 is 35. Negative 30 plus 35 is 5. So, because our original term started with a quadratic and we're taking out one of the x's, our new term will start with a linear. And our linear term is 1, or just x. Hey, look at this. Our first term was x. Then our constant term will be 7, leaving us with a remainder of 5. All of it just like what we did before, but a lot cleaner and a lot faster. Let's try the second one, which I remember being very long. So first thing I'm going to do, put in my coefficients. 2, 6, 5, remember the 0, and the negative 45. Then my 0 in this case, and then over here, what I want to put in is 3. So let's see, this becomes 2. 2 times 3 is, negative 3. So 2 times 3, negative 3 is negative 6. That's a 0. 0 times negative 3 is 0. The 5 plus 0 is 5. 5 times negative 3 is negative 15. That drops down to being negative 15. Negative 15 times negative 3 is positive 45, which is a 0, meaning no remainder. So let's see. It started as a quartic, so this is now a cubic. 2x cubed, no x squared, plus 5x minus 15. And sure enough, exactly what I had written before. So we've already seen this page, so let's move on. Here's another example we can do real quick just to show you. Now, I do want to warn you, sometimes these problems can go a little off the rails because we're dividing things that really shouldn't be there. So first, 5, negative 6, 4, negative 1. Then the 0 here is positive 3. So dropping down, 5 becomes 5. 5 times 3, 15. Negative 6 plus 15, 9. 9 times 3, 27. 27 plus 4, 31. 31 times 3, 93. Negative 1 plus 93, 92. Meaning our final answer would be, this started as a cubic, so it becomes a quadratic. 5x squared, this is the remainder, plus 9x plus 31 and 92 over x minus 3. Okay, let's try this one. Our coefficients are 1, 4, 1, negative 6. And our 0 is negative 1. Let's see, this drops. Negative 1 times 1 is negative 1. 4 minus 1 is 3. 3 times negative 1 is negative 3. 1 minus 3 is negative 2. Negative 2 times negative 1 is positive 2. Negative 6 plus 2 is negative 4. Meaning, this is the remainder. Because it started as cubic, it's now quadratic. X squared plus 3x minus 2 with a remainder of negative 4 over x plus 1. All right. Now, we are going to use long division or synthetic division to determine whether x plus 2 is a factor of the following polynomials. Now, here's a little hint. If something's a factor, it means its remainder must be, well, let's think. We know that 7 is a factor of 35 because 35 divided by 7 is 5. It's a nice, perfect whole number. Whereas if I said 38 divided by 7, that leaves us with a decimal or a remainder of 1. So we want the remainder to be 0. You know what? I'm going to write that in a different color. There we go. That is a horrible looking 0. One more time. There we are. 0. So now that we know that, let's try one. 2x squared plus 7x plus 6. So, first thing I'm going to do, 2, 7, 6. My 0 in this case, x plus 2, is negative 2. So it drops down. 2 times negative 2 is negative 4. 7 minus 4 is 3 times negative 2 is negative 6. That means my remainder is 0. So the answer is yes, it is a factor. Let's try it again. Ooh, this one has an x cubed. So let's see. 1, 2, negative 5, and negative 10. By the way, remember we have to keep checking to always make sure there aren't any missing terms, which there are not in this case. So then negative 2 again. So let's see. 1, negative 2 is 0. 0, negative 5. Negative 5 times negative 2 is positive 10. That gives us a 0, which means, once again, yes. We can also use synthetic division to evaluate a function. The remainder theorem says that if a polynomial is divided by a factor of x minus a, where a is constant, the remainder is, in fact, p of a. So in other words, if we want to find p of 4 in this equation, we could try to plug it in, or, and this is the better option here, we're going to put in our values. So let's see, 1, negative 5, 4, and 12. Uh-oh, I didn't notice something right here. There should be an x cubed in this spot. So since there isn't, I'm putting a 0. Good thing I gave myself lots of space accidentally. So I do this. Let's see. I'm wanting p of 4, so over here I'm going to write 4. So 1 comes down. 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. 16 minus 5 is 11. 11 times 4 is 44. 4 plus 44 is 48. 48 times 4, well, let's see. 50 times 4 is 200 minus 8, so that is 192 plus 12. That gives us 204. And for the record, if you were to plug this into a calculator, you would discover that you got the exact same thing. Using either long division or synthetic division, and given the factor, completely factor the polynomial below. So this is an example of one that we haven't learned how to factor yet. So here's what we'd want to do in this case. We would want to take this factor, and then we'd want to use this polynomial and divide the factor we already know. So let's see. Cube term, square term, linear term, constant. We're not missing any. Negative 3. That would be the 0. At that point, 1 times negative 3 is negative 3. Negative 4 plus negative 3 is negative 7. Negative 7 times negative 3 is positive 21. The difference between 9 and 21 is 12. 12 times negative 3 is negative 36, which is good because we already knew that this should be a factor. So our final version of this is 1. So I'm just going to write x squared minus 7x plus 12. So if I'm factoring this, I'm going to factor out the number 12. I want to find two numbers that multiply to be 12 and add up to be negative 7. So they're both going to be negative. So let's see, 1 and 12, nope. 2 and 6, no. 3 and 4, well, they add up to 7, so negative 3, negative 4, those work. Now, I'm going to tell you all a little secret about factoring. When our leading coefficient is 1, which means basically I have nothing written here, and you may have noticed I originally started writing the number 1, so the leading coefficient is 1. Then, when we are factoring, we don't have to use box or grouping. We literally just have to do this. X minus 3 times x minus 4. Now, I will remind you, we did have one more term that we have to also include. So this would be our final factored version of the original polynomial. All right, it's our last problem. The volume in cubic feet of a workshop storage chest can be expressed as the product of its three dimensions given by the function v of x equals x cubed plus 7x squared plus 10x. The depth of the chest is given by the factor of x plus 2. Find linear expressions for the other two dimensions. So to be honest, originally if I was just trying to solve this myself, I would have said, well, this is really x times x squared plus 7x plus 10. Since this is x plus 2, I know it has to be x plus 2 times x plus 5. I could tell you that, but here's the thing. That's not using division. And this one's easy, but they're not always. So here is how I would do this one if I wanted to use synthetic division. So let's see, our terms. Our cubic term, 1. Quadratic term, 7. Linear term, 10. Constant, 0. Then, right here, our 0 for x plus 2 is negative 2. So, 1. 1 times negative 2 is negative 2. That becomes 5, because 7 minus 2 is 5. 5 times negative 2 is negative 10. That makes this a 0, which means nothing. Also nothing. Our final equation would end up being x squared plus 5x. And if I factor that out, it is x, because there is a common factor of x between both of those, times x plus 5. Meaning those are the other two dimensions. That's the video. That's all that you need to know about this. If you want to know more about synthetic division, you can come talk to any of us here, and we will help you out a little bit more. Thank you very much for watching. Have a good day.